Good morning. Today we're going to be covering Algebra 2 Lesson 9.2, Nth Roots, and we're going to simplify these nth root expressions. And remember, when we talk about nth roots, we're talking about radicals that have different types of roots. So you're used to seeing square roots, but you'll notice here this one has a little 3 in the little crook, which is called the index, okay? And so that's a cubed root. And you could have a 4th root, or a 5th root, or a 10th root, or a 23rd root, or whatever the root is, which is why we have nth roots, okay? All right, so I want us to take a look at, this kind of a recollection of what goes on in all the middle school and algebra 1 material that we've done in the past. So let me just first of all write out here, we've got a radical number, okay, with some index, which we'll call I, okay, and some power, which we will call P. And so, you've noticed a number of things about this, but what we're going to show you is that you can look at this relationship a little bit differently. Because if you remember, if this was, let's say x to the 4th, and this was a square root, so this was an index of 2, that would be the same as taking the power and dividing it by the index. So we could rewrite this as whatever that number is outside of the radical sign, but in fractional form with the power in the numerator and the index in the denominator, okay? So that's something that's really important to remember, and so I would suggest that you go ahead and make sure you remember this and go back through it. This is a very important concept. Okay, so let's see, I kind of got a little smushed there, but I think you can see it. N to the P, radical, right? Now let's rewrite it over here. So again, index and n to some power is the same as n to the p over I, and that's going to be your exponent, okay? Some fractional form of an exponent. All right, so let's just look at what we've done in the past. So if you'll remember, we have x to the 3 times x to the 2, and the old-fashioned way of figuring out what that was just simply to go ahead and write it all out. So we'd have x times x times x, that's x to the 3, times x, that's x to the 2. And when you add all those x's up, 1, 2, 3, 4, 5, you'd end up with x to the 5. So that's the old-fashioned spread out way to do it, and it works. It's just it takes a long time to do it. Here's another example. X to the 5 divided by x to the 2. Well, we could write the numerator out as x times x times x times x times x, 5 x's, divided by x to the 2. So that's x times x. Now, if you remember, no, that's exactly what I had said, is that I'm going to be recording, so don't worry about it. Don't worry about it, I'm recording, okay? Good? No problem. Okay, so, sorry about that. We had somebody just politely telling me that I'm recording, and yes, I am. So, if then you want to simplify this. What you just simply do is you take an x out of the numerator to the denominator, and that leaves you with 1 there, because x divided by x is 1. And the same thing over here. Take out the x divided by x, that's 1. And that leaves with x cubed. Okay? So again, it's tried and true, and it works. All right. Now here in number 3, we have x to the cubed raised to the second power. Now when you do that, what you're really doing is taking x cubed times x cubed. All right? So you've got x cubed twice. That's y to the second power. And that's addition. You're adding the powers, and so you end up with x to the 6th. Okay? All right. Now, let's go to this radical. Cube root. So what you've got here is an index of 3, so that means that you're going to have groups of 3. Groups of 3. So we can rewrite this like we did up here as a fractional exponent. And so what we would do is we would take the radical, and in this case it's x, right? And its power is 10, right? So to the 10 over, and its index is 3. So we end up with x to the 10 over 3. I'm going to make this just a little bit larger so you can see that that's an exponent up there. Okay? All right. And now, what else could you do with this? Well, you've got 10 over 3, so we know that 10 over 3, what does that divide into? Well, 10 divided by 3, 3 times 3 is 9, so that's 3 with a remainder of 1. So I could easily, very quickly convert this now into its simplest form, because we want to simplify, right? So if I simplified this, I would have 3x is coming out, so x times x times x is x to the 3rd. What am I left with under the radical? 1x. And remember, this is cube root. So let's move this over just a little bit. So this is x to the 3, and then this is an index of 3 because it's still cubed root. And we're left with 1x down here inside. Okay. So we've just very carefully and quickly simplified this radical by converting it into a fraction. And dividing, since we have 10 over 3, it's an improper fraction, we realized we had 3 with a remainder of 1. So 3x's went out, x times x times x is x cubed, and 1x remained under in the cube root jail, and it's to a power 1. So we could have written it x cubed times x to the 1/3, but we want to keep it in this form whenever we have people refugees escaping from the radical jail. Okay? All right. Let's move on. All right. So we want to write, in this first example, we want to write this expression in radical form. So these are all, if you look at them, fractional exponents. So it's pretty easy. Remember that the numerator is always the power and the denominator is always the index, right? And you might want to remember that n here to the power divided by the index equals, again, the radical with the I in the index and times some number to the power. Now we can go back and forth with this. We could switch these around. We could go from one form to the other form, or this form to that form. All right, so we're going to change this now. So we're going to the index is 3, so I'm going to have the cubed root. And then I've got x, and the power is 4. And that's all it is. And it's a great answer. Okay. Next one. The index is 5. Okay, so I'm going to have the 5th root of x and the power. Okay, because this is p, or power, over the index. Okay, so you have to realize you're switching those around like that. All right, third one, and oh, again, perfectly acceptable answer. So what do we have here? So this is the power. This is the index. If you can't remember it, put it up there. So my index is 2, so I could do it this way. Now, we know that index is 2, and the power is 3. But you should understand, though, that this is really implied. This 2 is always implied. So when you write this into Delta Math, it'll want the 2 implied, so it's just going to look like this. It's going to be x cubed. So this is square root of x cubed with an implied 2. Going in here. Okay. All right. So let's look down at the bottom. Now here we have radical expressions, and we want to put them into exponential form. So we're doing just the reverse. So remember, this is the index, this is the power, and we're going to change it so that we've got power over index. So we take our root, our x, our power always goes in the numerator, right? Our index goes in the denominator. So in this case, the power is 4 and the index is 3. And that's our answer. Okay, in this case, we have the 4th root of x, and there is no power there, but it's implied. It's an implied 1. So this is implied. And so we're going to rewrite this as x to the 1 over 4. And that's our answer. So notice you have to pull out that implied 1 to show this, and you have to pull out the implied 2 to show it in up here. You've got to pull these out so that here the 2 is implied and it disappears, but here we're going the other way around. We've got to show the 1. All right. So now, what do we got over here? Again, this is implied 2. So 2 in here, right? So that means I've got x to the, what do we put first? We always put the power first, so 5 over 2. All right. Good enough. And a good answer. All right. So now we want to simplify the following expressions. So here, pretty simple. Same base, you add the exponents. All right, so that means I've got base of x here, and I'm going to add together the exponents, so 2 plus 5 is 7. And I got x to the 7. All right, now over here, fractional exponents. So what do we got to do here? Well, this is kind of interesting. We can use fractional exponents and just find the common denominators. So find common denominators. Find common denominators for fractional exponents. So let's just write this out again. I've got, let's see here. This is 2, base is the same, right? 2 to the 1/3. Okay, plus the 1/6. Now, if you're looking at this, it looks like I could multiply 1/3 times 2 over 2, right? And we'll get the same denominator, which is 6. So we end up with equals 2 to the 2/6 plus 1/6, and of course that equals 2 to the 3/6, which simplifies to 2 to the 1/2. Okay, pretty simple. Now, you know, if we were going back into radical, what would this become? Remember the power over exponent. I'm sorry, power over index. Okay. So power over index, so that means this would be square root of 2, right? Square root of 2. All right, let's go on. All right, so now, this is 1, by the way. 2 to the 1. So I've got 2 to the 1/3 times 2 to the 3/5. So you've got to rewrite this, and you want to use exponents, which is what we're doing, fractional exponents. Right? Okay, so 1/3 plus 3/5, right? What would that be? So let's think about it. We're going to probably have to do, we'll have 2 to the 1/3 plus 3/5. And so it looks like we're going to have to multiply, well, what could we do? What could we do? Let's think about this. We could simplify this. We could, you know, multiply this times 5 over 5, and this times 3 over 3, and we could go through all of that. But could we use our calculators? Well, let's find out. Let's try 2 to the 1/3. Now, how would we do that? Well, 2 to the and then let's put in parentheses 1 divided by 3 close the parentheses plus 3 divided by 5. Let's see what that does. 1.85, I don't know. Possibly that, you know, it might be worth that. Well, think about that. I'm going to tell you that yes, you can actually do this using a graphing calculator. But let's just go ahead and, for the moment, let's change these into fractions that have common denominators. So I would multiply 1/3 times 5 over 5, and I would multiply 3/5 as by 3 over 3. So we end up with 2 and this is becomes, well, let's see here, 5 over 15 plus this is 3 times 3 is 9 over 15. What's 9 and 5? That's 14. So that's 2 and 14 over 15. And let's just make that a little bit bigger. So 2 to the 14th over 15. That's all there is to it. And that's a perfectly valid answer. Now, could we set this into radical? Sure. It could also be, let's put it over here. What would that be? That's power over index. So this would be 2 to the 14th squared, 15th root of 2 to the 14th. It could be that, or this. Now, what would, again, Delta Math want to do with something like this if you were left it here? They might want you to multiply 2 to the 14th out. That would be a huge number. Check it out and see which way it will go. But we know that we would have one or the other. Okay? All right. Let's look at the next one, D. So here, this is an implied 2, and this is an implied 1. Okay, so this is 7 to the 1/2. And then this is times 7 to the 2/3. Okay, so we got 1/2 plus 2/3. All right, so again, we could change the 1/2 into, we could do these into sixths. So let's do this into sixths. So this is 3/6, right? So that equals 7 to the 3/6 plus, and then this is 4/6, which is 7 to the 7 over 6. And that would change into, if we're going to radical form, 7 to the 7th power, and it's radical 6. So it's 6th root of 7 to the 7th power. That's a 7 there, by the way. Okay. All right. So pretty simple, pretty easy to do. Okay. All right. We want to express these in simplest radical form. That means we want to get these into radical sign from what they're in. So this is 4 to the 4 over 3. So that equals cube root of 4 to the 4th, right? Now, we want to simplify. We want to get it into simplest radical form. So to do that, we've got, well, we have 4 4s under this. So this is the same as the cube root of 3 to the 4 times 4 times 4 times 4, right? And we know that we can take a group of 3 out. Now, when we do that, 2 gets shot, 1 comes out. So we get a 4 out here. And then we're left with, under the radical sign, cube root of 4. And that's our answer. Now, could we also simplify 4? Yes, that's into 2 times 2, but that's only a pair of 2. So this is as far as we can go. Okay. All right. Now here we have to multiply the powers, and so this is 1/3. This is 2. We got these messy fraction. Messy parentheses around this. This is really 2 over 1 times 1 over 3. That's the easiest way to look at it. So when you do that, you just multiply across. 2 times 1 is 2. 3 times 1 is 3, right? So that's 30 to the 2/3. right? Which equals the cube root of 30 squared. Now 30, can we do anything with that? Well, we know that's 3 times 10 times 3 times 10, and 10 is 2 times 5. So that's 3 times 2 times 5 times 3 times 2 times 5. Do we have any groups of 3 we can take out? Well, no, I have 2 3s, 2 2s, 2 5s. So we don't get we don't get 3. So we don't get 3. So you can't simplify. So the only thing we can do is take the 30 squared and multiply that together, and you get the cube root of 900. Okay, and that's your answer. All right, 27 to the 1/3. All right, so that equals, well, we got well, let's change this. This would be putting it into radical, cube root of 27, and it's 27 to the 1, right? And that factors into 3 times 9, which is 3 times 3 times 3. So we could have cube root of 3 times 3 times 3. So there we can go ahead, and we've got a group of 3. 2 get shot, 1 escapes. So you end up with an answer of 3. And that's your answer. Okay. All right. I'm going to stop this here, and we'll do a part 2. So I'll be right back.